Section 1.6 is the second section in a row that each of the problems that we're going to be asked to factor has two terms. I separated the sections specifically because section 1.5 we were dealing with squares, and in section 1.6 we're dealing with cubes. And in order for a problem to be a cube, it needs to have a couple different criterias. And in the world of cubes, just like in the world of squares, we have sums and differences of cubes. To be a difference of cubes, you need a minus sign. To be, to be a sum of cubes, you need a plus sign. That's the only visual difference there's going to be between differences and sums of cubes. If we have letters, letters have exponents that are multiples of 3. Similarly, sums of cubes, the letters have exponents that are multiples of 3. So I might see an x cubed because 3 is a multiple of 3, an x to the 6th, an x to the 9th, and x to the 12th. In either one of these. And it doesn't have to be x's, it could be y's or z's or w's. As long as the exponent is a multiple of 3, that gets it the possibility of being a cube problem. The numbers are perfect cubes, and these are less common numbers. Whether I'm doing a sum of cubes or a difference of cubes, any number needs to be a perfect cube. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so forth. So if I'm living with this kind of world, I can identify something as a sum or difference of cubes. For example, if I wrote a problem like x cubed plus 64, this would cancel as a sum of cubes. Specifically, it fits the criteria to be a sum of cubes. If I look at my criteria, it needs to have two terms. I didn't write that down, but I should have. You need two terms. It doesn't work. I can't classify something as a sum of cubes or a difference of cubes if there's other than two terms. So this has two terms. There's a plus sign between. The exponent has a letter of 3, which is the letter has an exponent of 3, which is a multiple of 3. And 64 turns out to be a perfect cube. I'm going to show you some perfect cubes and how we're going to need to understand these in a second. I'll write another problem down, like 125 y to the 6th minus 8. I classified this as a difference of cubes. It has two terms. The minuses between, the letter has an exponent of 6, and 6 is a multiple of 3, and 125 and 8 are perfect cubes. The big skill that's going to be necessary in this section is to be able to decompose perfect cubes, and I'll show you how to do that. Real specifically, I say 1 is a perfect cube because there's 3 identical numbers that multiply out to be 1. So 1 is in my list of perfect cubes because 1 times 1 times 1, 3 identical numbers multiply out to be 1. 8 is a perfect cube because 2 times 2 times 2, which is 2 cubed, equals 8. A number is a perfect cube if it can be written as the product of 3 identical numbers, because the product of 3 identical numbers is a shorthand for that. Shorthand of that is that number cubed. 27 is a perfect cube because it's 3 times 3 times 3. 64 is a perfect cube because it's 4 times 4 times 4. And 125 is a perfect cube because it's 5 times 5 times 5. So when we factor in section 1.6, each of the numbers is going to be a perfect cube. And we're going to need to be able to decompose that perfect cube into its the 3 identical numbers that multiply to be it. I made up a sheet a little bit earlier because I knew I was going to need it. I'm going to need to just decompose perfect cubes into the product of 3 identical numbers. I'm also going to need to be able to decompose letters that have exponents of multiples of 3 into the product of 3 identical factors. And if I had a number like x cubed can be written as x times x times x, because I'd add the exponents and that would be a true statement. So every variable, letter should I say, or number in this section is going to be able to be decomposed into the product of 3 identical factors. If I wrote the letter y to the 6th, if I divide the exponent of 6 divided by 3, y to the 6th is y squared times y squared times y squared. If I wrote z to the 9th and I divide the exponent by 3, z to the 9th is z cubed times z cubed times z cubed. This is an important skill, and it's really the only important skill in section 1.6. Every problem in section 1.6 is either a cube with a minus or a cube with a plus. The numbers are going to be perfect cubes. These are the kinds of numbers I'm going to see. The letters are going to have exponents that are multiples of 3. These are the kinds of letters I'm going to see. And for any perfect cube number that I see, I'm going to need to be able to decompose it into 3 identical factors. Any letter, I'm going to need to decompose it into 3 identical factors by dividing its exponent by 3. How did I get 216 as 6 times 6 times 6? On my calculator, I hit Shift and then the square root key. That gave me the cube root key. And then I typed 216. And I hit Enter, and it gave me 6. And that told me that 6 times 6 times 6 is 216. Similarly, if I hit Shift and square root and type 343, the cube root of 343 is 7. That means 343 is 7 times 7 times 7. I'm going to keep this sheet handy because it's going to be important. In the world of cubes, it turns out that both sums of cubes and differences of cubes factor. If I can identify something as a sum of cubes, it's going to factor, and there's an odd looking template for it to factor. The first parenthesis has 1 sign and 2 terms. The second parenthesis has 2 signs and 3 terms. The signs are plus, minus, plus when I go to factor a sum of cubes. Unlike sums of squares, which are prime, sums of cubes factor. And difference of cubes also factor. And they factor oddly. They factor into 2 parentheses. The first parenthesis has a minus sign, and the following parentheses has a couple of plus signs. I'm going to keep this sheet handy. It's going to help me factor, I think, every problem in this section. I'm going to factor and check a couple, and then I'm just going to factor without checking. So problem 2 fits the world of sum of cubes. It's a sum of cubes. There's 2 terms. It has a plus sign between. The exponent is 3, the number is 64, so it's a perfect cube. And when I go to factor sums of cubes, immediately I write down my template next to the problem. First parentheses has a plus sign, second parentheses has both a minus and a plus sign. So these are unbalanced parentheses. First parentheses, one sign and two terms. Second parentheses, two signs and three terms. Now underneath each of the terms in the problem, I'm going to write why it's a cube. Y cubed, I'm going to divide the exponent by 3 and say y cubed is y times y times y. In order to factor cubes, I need to decompose each of the terms into 3 identical factors. 64, I'm going to write as 4 times 4 times 4. So I have my template, and I've written underneath why it's a cube. Now I'm going to fill up my parentheses. The first parentheses gets 1 from each pair. So 1 from the pair of y's and 1 from the group of 3, 4, should I say. So in the first parentheses, I get 1 from each group. In the second parentheses, I'm going to say I'm going to pair and multiply. So the first pair that I can make from my groups that I have written is y times y. Made a pair, I'm going to multiply it. The second pair I can make is y times 4. And the third pair I can make is 4 times 4. So I made 3 pairs, and I put them in order into 3 spots in the right parentheses. My left parentheses is done. It's a y plus 4. My right parentheses, the y times y that I have written in there, I'm going to multiply out to be a y squared. The 4 times y after the minus sign I'm going to write as 4y. And after the plus sign, the 4 times 4 I'm going to write as 16. I claim this is the answer. I'll check it. The second parentheses is always prime. There's no need to try to factor it. Checking is kind of ridiculous, but I should check, 1 or 2 of these, but maybe no more than 1 or 2. If I wanted to check to make sure that this complicated answer multiplies out and simplifies to the simple problem, I need to do 6 multiplications that we learned in Chapter P. I'm going to start with the y in the left parentheses. I'm going to multiply it by the y squared in the right parentheses. I'm going to multiply the y in the left parentheses by the minus 4y in the right parentheses. I'm going to multiply the y in the left parentheses by the 16. I'll do the same with the 4. Take the 4 in the left parentheses, multiply it by the y squared in the right parentheses, the 4 in the left parentheses, multiply it by the minus 4y, and the 4 and multiply it by the 16. First multiplication, I add the exponents of 1 and 2 and get 3. Second multiplication, I leave the negative 4 up front, add the exponents on the y's and get a y squared. Third multiplication is positive 16y. Fourth multiplication is positive 4y squared. Fifth multiplication is minus 16y. Last multiplication is plus 64. And the beautiful thing is, I have opposites. The negative and positive 4y squareds cancel. The positive 16 and negative 16y cancel. And I'm left with this y cubed and that plus 64. Because that's exactly the original problem, my answer is correct. Let's do 3 together. 3, I need to break it down and make it a cube. So the x cubed I'm going to write as x times x times x. The 8 I'm going to write as 2 times 2 times 2. So that makes it a cube problem. It's a cube problem if each term can be written as 3 identical factors and there's 2 terms. This is a cube with a minus, or a difference of cubes, so the signs are minus, plus, plus. I'm going to go to factor this. I'm going to create 2 parentheses. First parentheses has 1 sign, it gets 2 terms. Second parentheses has 2 signs. In the first parentheses, I get 1 from each group. The nice thing about these cubes is they factor identically except for the signs. So 1 from the group of x's, 1 from the group of 2's. The second parentheses I make pairs, and I multiply. Usually I do this in my head, but I'll do it manually right now. So I'm going to lead off that parentheses with x times x, that's the first pairing, and then x times 2, that's the second pairing, and then 2 times 2, that's the third pairing. My answer for number 3 is going to be first parentheses has an x minus 2, second parentheses, x times x is x squared, x times 2 is 2x, 2 times 2 is 4. I claim that's the answer. Second parentheses is always prime. Let me check, and this will be the last one I check. So to check, I need to multiply x minus 2 times x squared plus 2x plus 4. 6 multiplications need to be done. I need to take the x in the left parentheses, multiply it by the x squared in the right parentheses, the x in the left parentheses, multiply it by the 2x in the right parentheses, the x in the left parentheses, multiply it by the 4, and then the same with the minus 2. Minus 2 in the left parentheses times x squared in the right parentheses, minus 2 in the left parentheses times 2x in the right parentheses, minus 2 in the left parentheses times 4 in the right parentheses. As I do the multiplication, first multiplication I add the exponents and get x cubed. Second multiplication, they're both positive, so I'll put a plus sign. I'll add the exponents on the x's and leave the 2 and get a 2x squared. Third multiplication, they're both plus, I'll put a plus sign. I'll leave the 4 and the x next to each other. Fourth multiplication, that's just negative 2x squared, I could see it there. Fifth multiplication, I get negative 4x. Last multiplication, I get negative 8. When I'm checking these cubes, I get double canceling. Here, the 2x cubes, 2x squareds are opposites, they cancel. The positive and negative 4x are opposites, they cancel. And this leaves me with x cubed minus 8, which is identical to the original problem. So I know that my answer is correct. So I'm not going to factor every single problem because they get redundant. So I'm going to skip on to the next page. And you should probably do all 4 problems on this page, 1, 3, 5, and 7. But I'll make myself get lazy. Oh, wow. I really liked problem 10 and 12. They're the same problem. Let me factor, well, I'm not going to factor 12 because that's the same. Under y cubed, I'm going to call this y times y times y. I'm going to divide the exponent by 3. Under 27, I'm going to write 3 times 3 times 3. I'm going to make 2 parentheses. First parentheses has a plus, the second parentheses has a minus and a plus. Always the first parentheses has the same sign as the problem, and then whichever sign I put in first, I flip. The last sign is always plus. To fill up the parentheses, the first parentheses gets 1 from each group. 1 from the group of y's, 1 from the group of 3's. Second parentheses I pair and multiply. First pair is going to be y times y. Second pair is going to be y times 3. Third pair is going to be 3 times 3. And I'll get something that I'll call an answer in a second here. The y times y multiplies out to be y squared. The y times 3 multiplies out to be 3y. The 3 times 3 multiplies out to be 9. And so that's going to be the answer. I'm done with that. Let's move down to something more complicated. And I'll do problem 13 with you. I know it is a cube with a minus, but before I commit to it, let me work on the 8x cubed. The 8 is 2 times 2 times 2. The x cubed is x times x times x. So 8x cubed is going to be 2x times 2x times 2x, because 2 times 2 times 2 is 8, and x times x times x is x cubed. The 27 is going to be 3 times 3 times 3. So now I have the components that are going to go into the parentheses. This is a difference of cubes. It's minus, plus, plus. Always when I do the signs, I get the same sign as the original problem. Then I flip the sign, and then the last sign is plus. Usually we do this SOP acronym. Keep the sign, flip the sign, and plus. So to memorize the signs, I keep the sign that the problem has, then whatever sign I put in the first parentheses I flip, the last sign is always plus. First parentheses, I get 1 from each grouping, so I get one of the 2 x's and one of the 3's. Second parentheses, I pair and multiply. Usually I multiply in my head and I don't show this step, but just in case you need it, I usually would go right to the answer. So first pair, second pair, last pair. So for an answer, I'm going to say it's 2x minus 3, and then 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 3 is 9. Both squares, cubes, sums of cubes, and differences of cubes factor. They all can be checked. Second parentheses is always prime. I'll do 16 real quickly. It's a cube with a plus. So I'm going to keep the sign, keep the plus sign, flip the plus sign from plus to minus, and then put a plus in. The 125 is 5 times 5 times 5. The x cubed is x times x times x. So for the 125x cubed, I'm going to write 5x times 5x times 5x. And for the 64, I'm going to write 4 times 4 times 4. First parentheses gets 1 from each grouping, one of the 5x's and one of the 4's. Now I'm going to efficiently fill up the second parentheses. I'm going to start my second parentheses with 5x times 5x. I'm going to multiply the 5's and get 25, add the exponents on the x's and get x squared. Second item, in the second parentheses, I multiply 5x and 4, which is just multiplying the 5 and 4 and getting 20, and leaving the x. Third slot in the second parentheses, I multiply the 4 and 4 and get 16. Second parentheses is always prime, so the answer to this is 5x plus 4 times 25x squared minus 20x plus 16. These really aren't bad. I won't do every single even problem because it just feels like overkill. Let me work on 20. And if you want to skip a couple of these, if you feel good about these, you don't need to do every single problem. So 20, the 27 is 3 times 3 times 3. And the x cubed is x times x times x. So the 27x cubed, I'm going to write as 3x times 3x times 3x. And the y cubed I'm going to write as y times y times y. I'm going to make my unbalanced parentheses, keep the sign, flip the sign, and plus. Last sign is always plus. First sign is always the same sign that the problem has. Middle sign is the opposite sign of the first parentheses. We use SOP, same sign, opposite sign, plus. First parentheses gets one of each, so one of the 3 x's and one of the y's. Second parentheses, I'll multiply 3x times 3x, multiply the 3's and add the exponents on the x's and get 9x squared. Second spot of the second parentheses, 3x times y is 3xy. And third spot in the second parentheses, y times y is y squared. Second parentheses is always prime. It can't be broken down any further. This 22 and 21 are worth doing. Let's do 21 together. For 21, I have to divide the exponent by 3. And for the x to the 6, I'm going to write under it x squared times x squared times x squared. And the y cubed I'm going to write as y times y times y. I make my unbalanced parentheses. First parentheses, I keep the sign that the problem has. Second parentheses, I flip the sign from my first parentheses, and I end it with a plus. So keep the sign, flip the sign, plus. First parentheses gets 1 from each grouping, one of the x squareds and one of the y's. And then the second parentheses, I make pairs. The first pair is x squared times x squared. To multiply those, I add the exponents and get x to the fourth. The second pair is x squared times y. I just write those next to each other. The third pair is y times y. I add the exponents and get y squared. Second parentheses is always prime. And I'll call that done. Since it's here, let's do 24. I don't have that many more to do. 64 is 4 times 4 times 4. I divide the exponent of the 6th by 3 and get 2. So 64x to the 6th is going to be 4x squared times 4x squared times 4x squared. And 1 is going to be 1 times 1 times 1. So the items I'm going to need for my parentheses are 4x squareds and 1s. I'm going to keep the sign, flip the sign, and then plus. First parentheses gets 1 from each grouping, 1 of the 4x squareds and 1 of the 1s. Second parentheses, first pair, 4x squared times 4x squared. I multiply the 4s and get 16. I add the exponents and get 4. Middle multiplication, 4x squared times 1 is 4x squared. Last multiplication, 1 times 1 is 1. Second parentheses is always prime. There's a good answer. Eventually we'll get some common factors. Let's jump down to one that has a common, well, let's do 25 together. For 25, 125 is 5 times 5 times 5. The exponent of 9 I'll divide by 3 and get it cubed. So this is going to be 5x cubed times 5x cubed times 5x cubed. And the y to the 6, I divide its exponent by 3 and get a y squared. So y squared, and y squared. Make two parentheses. First parentheses, I keep the sign, same sign that the problem has. Second parentheses, I change the sign that I put in the first parentheses, and it ends with a plus. First factor, I get 1 from each grouping, so I get a 5x cubed and a y squared. And then I make pairs. First pair, in the second parentheses, I multiply the 5s and get 25. I add the exponents on the x's and get x to the 6th. Second pair, I just leave the 5x cubed and the y squared next to each other. Last pair, I add the exponents on the y's and get a y to the 4th. The next rest of the problems in the section, I think they mostly have common factors. I'm not sure that that's the case for all of them, but I think so. In problem 28, let me do 30, just because I'm doing all these minuses. Let's do with them on the plus. In problem 30, there's a common factor of a 2. I'm going to factor out a 2. Up front, I'll be left with an x cubed. And 128 divided by 2, if I can get it to show on my calculator, 128 divided by 2 is 64. Maybe I'll bump up the light here. I don't have the light on. So anyways, inside the parentheses, I'll get a 64. The common factor of 2 is going to be part of my answer, but it's not going to impact making the double parentheses. The double parentheses, I keep the sign, I flip the sign, and then plus. Underneath the x cubed, I'm going to write 3 x's. Underneath the 64, I'm going to write 3 4s. Now my double parentheses, I get 1x and 1 4 to lead off the first parentheses. Second parentheses, x times x leads it off, that's x squared. X times 4 is in the middle, and that's 4x. 4 times 4 ends it up, that's 16. Let's do 31 together just in case you need. You can pause the video and then just check your answer. Maybe that's a nice idea. For 31, there's a common factor of an x that I'm going to factor out. That's going to leave me with an x cubed and minus 8. That common factor of x is going to be part of my answer, but it's not going to impact the making the two parentheses. The signs in the parentheses, keep the sign, change the sign, and then plus, same opposite plus, same sign as minus, opposite of minus is plus, and then always end with a plus. The x cubed I think of as x times x times x. The 8 I think of as 2 times 2 times 2. First parentheses gets 1 from the group of x's and 1 from the group of 2's. Second parentheses I do x times x and get x squared. I do x times 2 and get 2x. I do 2 times 2 and get 4. That's my answer. I'm done. Second parentheses, always prime. Oh, let's skip around on these. Let's do 35 together. I need to plot a common factor. 8's a perfect cube, 125 is a perfect cube. That's probably not keeping me from being able to factor. But the exponents on the x's aren't multiples of 3. That's keeping me from factoring. There's a common factor of x squared. So I should factor out an x squared. I'm going to keep the 8 up front. The x to the 5th, when I take 2 x's away, turns into an x cubed. After the plus sign, I took away the x squared. I'm left with a 125. I'm going to make my unbalanced parentheses. Signs are going to be plus, minus, plus. The second parentheses always has the opposite sign of the first parentheses followed by a plus. The first parentheses always has the sign of the problem. 8x cubed is 2x times 2x times 2x. 125 is 5 times 5 times 5. First parentheses gets 1 from each grouping, 1 of the 2x's and 1 of the 5's. And then I make pairs to fill up the second parentheses. 2x times 2x is 4x squared. 2x times 5 is 10x. I put them next to the right signs. 5 times 5 is 25. It would be awful to check, but that is a correct answer. Maybe just a couple more. 38's written in a bad order. I'm going to leave it in that bad order just because it's presented in that bad order. Maybe I wanted it in that order for a reason. There's no common factor. 64 is 4 times 4 times 4. Y cubed is y times y times y. First parentheses, I get the sign that the problem has, which is minus. Second parentheses, I change the sign that I just put in, and they all end with pluses. So for me, I'm going to get a 4 and a minus y in the order that the terms appear. Second parentheses leads off with 4 times 4, which is 16. And then 4 times y, which is 4y. And then y times y, which is y squared. I could definitely take the time to write my answers in a different order, but since the problem's written in a bad order, I'll just leave it in that bad order. Let's do maybe 39 together. In 39, the plus makes the signs go plus, minus, plus, assuming I can make things into cubes. 27 is 3 times 3 times 3. 64 is 4 times 4 times 4. 64x cubed is going to be 4x times 4x times 4x. First parentheses gets 1 from each grouping in order, a 3 then a 4x. Second parentheses, I'll do 3 times 3, which is 9. 3 times 4x, which is 12x. And 4x times 4x, which is 16x squared. Even though the order is kind of bizarre because the leading terms are written last, I'll live with it. One more problem. On 42, it has a plus. Assuming it's a cube, the signs are going to be plus first, and then minus and plus. 64 is 4 times 4 times 4. Divide the exponent of 9 by 3 and get x cubed times x cubed times x cubed. Leave my bad order. Put 1 4 and 1x cubed in the first parentheses. Second parentheses, I do 4 times 4, which is 16. 4 times x cubed, which is 4x cubed. And then add the exponents on the x's and get x to the 6th. Bad order, but the original problem is in a bad order, so I'll live with the funky order. I could write this in a better order, but I'm not gonna. So that's kind of everything for this section, and that's the last of the factoring techniques that we needed to learn. That's all we do. Everything else is just going to be learning to do these problems when they're scrambled, not all the same. And that's the next section.